This is the chapter of functions. In the chapter of functions, in this video, we are solving some of the problems for the practice. So the title itself is Some Problems on Functions chapter. Okay. So let us start with a concept. Concept is like this. There is a function f from non-zero reals to real numbers. That is minus infinity to plus infinity, except 0. In the middle, 0 is removed. Two real numbers. Such a function f is taken, satisfying the condition that f of x into f of 1 by x is equal f of x plus f of 1 by x. That is fx, f of 1 by x, two quantities, their product is equal to its sum. Such a thing is possible only in one type of the functions. The functions are of the form 1 plus minus x to the power n, where n is any real number. Maybe positive real number, negative real number, fraction, rational, irrational, anything. So once that product of two terms is same as the sum of two terms like that, one is f of x, other is f of 1 by x, then such possible functions are blindly you are supposed to remember f of x is equal 1 plus minus x to the power n. How we got that? Let us see here. So f of x, f of 1 by x is equal to f of x plus f of 1 by x is given. Then from this, that right side terms, bring it into the left side terms and add 1 in both sides. So that, so clearly the left side will be factorized like this. The factors are fx minus 1 into f of 1 by x minus 1 is equal to 1. We got it. Now in this product, you put g of x is equal to fx minus 1. Then clearly the equation becomes g of x into g of 1 by x is equal to 1. So that is same as g of 1 by x is equal to 1 by g of x. That is, g of x is a function such that in place of x, 1 by x is replaced. Then the whole function is reciprocal. That is 1 by g of x we will get. So what type of function it is? The function must be such that in that one, when x is replaced by 1 by x, the whole function must be reciprocal. Such a function is possible only if it is plus minus x to the power n. So g of x is plus minus x to the power n, but g of x is nothing but the fx minus 1. F of x minus 1 is plus minus x to the power n. Therefore, f of x is equal 1 plus minus x to the power n. This is exactly the concept. We have proved it. Okay. Then you see the next concept. The second concept is that same terms from non-zero reals to real numbers, satisfying that f of x into f of 1 by x plus f of x plus f of 1 by x is equal to 0. In the previous concept, these last two terms are there in the left side, in the right side. Now here it is in the left side only. All the terms are there in the left side only. All right. Then satisfying this condition, only the function which will fulfill this is minus 1 plus minus x to the power n. So blindly we are supposed to remember that once that above condition is given, we must get that idea is that f of x is minus 1 plus minus x to the power n. How it comes, let us see. Same thing, that f of x, f of 1 by x plus f of x plus f of 1 by x is equal to 0, adding 1 in both sides. Simply, then left side will be factorized like this. fx plus 1 into f of 1 by x plus 1 is equal to 1. Again, fx plus 1 is equal to g of x. When you substitute, then g of x into g of 1 by x becomes 1. Therefore, g of 1 by x is 1 by g of x. So again, g of x is a function such that When x is replaced by 1 by x, the whole function must be reciprocal. Such a thing is possible when g of x is plus minus x to the power n only. So once this is plus minus x to the power n, then fx plus 1 is plus minus x to the power n. Therefore, f of x is minus 1 plus minus x to the power n. So when this above condition is given, we are supposed to remember that function must be of the form of minus 1 plus minus x to the power n blindly. So this is exactly the concept. By making use of this, some of the problems which are given earlier. All right. So let us solve some, for the practice purpose, some of the problems. One problem is that there is a function f of x which is satisfying that f of x into f of 1 by x is equal to f of x plus f of 1 by x. This is very first condition. All right. And f of 3 is equal to minus 80. Then what must be f of 2? Because of that above condition in the concept 1 part, so f of x into f of 1 by x is f of x plus f of 1 by x, means that such a function must be blindly 1 plus minus x to the power n form. But here it is given that f of 3 is minus 80. Substitute that f of 3, 1 plus minus 3 power n is equal to minus 80, means that plus minus 3 to the power n is minus 81. It is possible when n is equal to 4 and minus sign is taken. Therefore, f of x will be 1 minus x to the power 4. Is only the function which will satisfy all those conditions in the above. Okay. So now in this one simply is asking f of 2 only. Simply substitute x is equal to f of 2 is 1 minus 2 to the power 4, which is minus 31 is the answer. With the same idea, with the other concept, one problem, f of x is such that f of x into f of 1 by x plus f of x plus f of 1 by x is equal to 0, and f of 2 is equal to minus 65. Then what is f of minus 2 is asking. Because of that condition, from the concept 2 we have discussed now, the fx must be minus 1 plus minus x to the power n. Right? So now f of 2 is minus 1 plus minus 2 to the power n is given as minus 65. From this, plus minus 2 to the power n is minus 64. It is possible when n is equal to 6 and minus sign is taken. Therefore, f of x will be minus 1 minus x to the power 4. Now he is asking f of minus 2 there. F of minus 2 again minus 1 minus of minus 2 whole to the power 6. That is again minus 65. So like that, if we remember those concepts, problem solving becomes very easy. That points we are supposed to remember. So like that, let us go to some more problems. This problem is that a real valued function satisfying f of x minus y is equal to fx into f of y minus f of a minus x into f of a plus y. It is there like that. Such a condition, f is satisfying where a is a given constant. Then, and also given that f of 0 is equal to 1. So from all that informations, what will be the f of 2a minus x is asking. F of 2a minus x is how much? So it can be solved very easily. That is, in the very first step, you put x is equal to 0 and y is equal to 0 in the given relation. Then becomes f of 0 is equal to f of 0 into f of 0 minus f of a into f of a. Right? So, but is given that f of 0 is given as the 1. When we substitute that, then f of a is equal to 0 you will get automatically. So from that substitution, you will get f of a is equal to 0. So in the given question, again, you substitute x is equal to a, then f of a minus y is equal to f of a into f of y minus f of 0 into f of a plus y. here f of 0 is equal to 1 is substituted, then we will get f of a plus y is equal minus of f of a minus y, because f of 2a minus x is asking I am replacing y with a minus x. Then it becomes that f of a plus a minus x is equal minus of f of a minus a plus x. So we will get f of 2a minus x will be minus f of x. So that is exactly the answer we are looking for. Okay, now let us see one more problem. The number of integers satisfying the equation modulus of x square plus 5x plus modulus of x minus x square is equal to modulus of 6x. How many integers are possible satisfying that equation? Because the modulus is there, when you remove the modulus, plus minus will come everywhere. In 3 of the places moduli is there. So first of all, inside the modulus quantity, when it becomes 0, let us see. First modulus part x square plus 5x, when it becomes 0? It becomes 0 when x is equal to 0 and x is equal to minus 5. That implies that for the 0 in the left side one thing, right side one thing. For minus 5 also, left side one thing, right side one thing. And similarly, second modulus x minus x square will become 0 when x is equal to 0 and x is equal to 1. And mod 6x, 6x becomes 0 at x is equal to 0, which is already taken in both of them. Therefore, I am not calculating separately. That implies that, so whole together, x is equal to 0, x is equal to 1, x is equal to minus 5. These are the breaking points of the interval we have to see. That implies that at exactly those points, in the left side one formula will be there, in the right side one formula will be there for all those numbers. Therefore, full real line is broken into 4 parts. Minus infinity to minus 5 one piece, minus 5 to 0 one piece, 0 to 1 one piece, 1 to infinity one piece. So like that, it is a full real line is divided by 3 points. Then the whole line is divided into 4 parts. In each part, let us calculate. The very first part is that. So the full real line is divided into the parts like that. The very first part is when x is lesser than minus 5, lesser than or equal to minus 5. In the leftmost part, I am calculating this. When x is lesser than or equal to minus 5, then that x square plus 5x will be positive. Therefore, modulus of x square plus 5x will be x square plus 5x only. And x minus x square will be negative. Therefore, it is minus of x minus x square. And 6x is also negative. Therefore, minus 6x. Definition of modulus. Modulus of something is same thing if that something is positive, minus of the same thing if that something is negative. So that is what I am using now. So when x is less than minus 5, first part x square plus 5x is positive. Therefore, modulus of that is x square plus 5x only. But x minus x square will be negative. Therefore, minus of x minus x square. And 6x is also negative. Therefore, it is minus 6x. Substituted there. That x square plus x square 2x square minus 4x is equal to minus 6x. Bring them here and simplify that. You will get x into x plus 5 is equal to 0. So the choices are x is equal to 0 and x is equal to minus 5. But x is equal to 0 is not there in our interval where we are searching for. That is x is less than or equal to minus 5. So in this part, x is equal to minus 5 is only the solution in the first part. Let us see the second part in between minus 5 to 0. So x is in between minus 5 to 0. So in this part, in between minus 5 to 0, that x square plus 5x will become negative. Therefore, it is a minus of x square plus 5x. And x minus x square is also negative. Therefore, that is also minus of x minus x square. And 6x is also negative. Therefore, it is minus 6x. When you expand that bracket and simplify that, you will get a minus 6x is equal to minus 6x for every x in the interval minus 5 to 0. That implies that in the interval minus 5 to 0, every real x will satisfy that condition, that equation. But he is asking only integral solutions. Therefore, you see only the integers from minus 5 to 0. Minus 5 is already included in the first case. Therefore, so it is minus 4, minus 3, minus 2, minus 1, and 0 also. 0 is also included in the second case. Okay. So in the second case, that is from minus 5 to 0, we found 5 solutions. That is minus 4, minus 3, minus 2, minus 1, and 0. Now the third part is that when x is in between 0 to 1, when x is in between 0 to 1, so because he is asking only at integers, yet 0 already we checked it in the second part. 0 is one of the solution. So the next integer is 1 only. That is only the other integer which is available in our interval where we are searching for. Therefore, it is enough to check at x is equal to 1. Yet x is equal to 1, when we substitute that, we found that it is a solution. It will satisfy the equation. Therefore, x is equal to 1 is also one of the solution. And then the next part is that when x is greater than 1, right? When x is greater than 1, in that case, x square plus 5x is positive. Therefore, x square plus 5x, and x minus x square is a negative. Therefore, it is minus of x minus x square, and 6x is positive. Therefore, it is 6x. When you simplify that, this is x square 2x square plus 4x is equal to 6x is possible only if x is equal to 0, right? But this x is equal to 0 is not there in the interval. X is equal to 0 is not there in the interval because we are searching for x is greater than 1 interval. So therefore, so the total solutions what we got is minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1. So the number of solutions are nothing but 1, 2, 3, 4, 5, 6, 7 solutions we got it. All right. This is the answer for this problem. You see the next problem. What is the range of the function 2x plus 3 if the range of this function 2x plus 3 when x is less than or equal to 1, a square x plus 1 if x is greater than 1 is set of all real numbers. It is given that the range of this function is full real numbers. Then what number of integral values of a is asking. So for this function, its domain is the full real line. He is saying that its range is also the full real. Then what should be the number of integral values of a is asking that. So let us solve it. So for that, let us try to understand its diagram geometrically, x-axis, y-axis, because that function is defined in 2 pieces. That pieces are separated at x is equal to 1. Therefore, first draw the line x is equal to 1. For when x is less than or equal to 1, it is given by the formula y is equal to 2x plus 3. When x is greater than 1, right side of it, it is given by the formula a square x plus 1. And this y is equal to 2x plus 3 meets the line at x is equal to 1. Now the right side piece suitably selected so that the range of fx contains the full real line. the right side piece location suitably selected so that the range of the function is the full real line. Suppose the right side piece is like this line, that is y is equal to a square x plus 1, like this. That is, this left side piece meets the line x is equal to 1 at 1 comma 5. Suppose the right side piece starts from above, then you can imagine one line like this in the middle, in between 1 comma 5 and 1 comma a square plus 1, like this line. So for this line having this value, there is no x such that f of x value is this much. That implies that this horizontal line is not intersecting the graph at all, means function cannot be onto, right? So its range is full real line, means it is completely onto function from R to R. Geometrical meaning is that every horizontal line meets the graph at least one point. But when the right side piece of the function is above like this, then this horizontal line cannot intersect the graph. Therefore, the function cannot be onto. But if the right side of the function cannot be onto when a square plus 1 is greater than 5. But if the right side piece is below from 1 comma 5, then every horizontal line meets the graph at least one point. Therefore, if that part of the graph, that is the right side piece, is like this in the down, then y is equal to a square x plus 1. That point is nothing but 1 comma a square plus 1. If that a square plus 1 is less than or equal to 5, a square plus 1 is less than or equal to 5, then function becomes onto. That is, a square is less than or equal to 4. That is, a is in the interval -2 to 2, closed interval. Now the integral values of a are required. So the integral values of a are nothing but -2, -1, 0, 1, 2. There are 5 integral values of a are possible, so that this function's range is the full real line. This is the solution. Okay, na? Now let us see the next problem. The equation 2 power minus mod x is equal to x square minus k is satisfied by the maximum number of values of x. Then what will be the range of k, right? This equation 2 power minus mod x is equal to x square minus k is satisfied by maximum number of values of x. Then what will be the range of k, right? In this problem, if it is given like this, we are supposed to think that 2 power minus x, y is equal to 2 power minus x is one graph, one function or one graph. This graph pieces are nothing but 2 power minus x when x is positive. Let us see its graph, x-axis, y-axis. That graph will be there like this. And this is y is equal to 2 power minus x, right? When x is positive. So in the right side of the y-axis piece only taken like this. When x is negative, it is a 2 power x. So that piece will be there like this. So right side part like this, left side part like this. This is exactly the graph of the left side function of our equality. Similarly, right side, and this point is 0, 1. So similarly, let us see right side function part x square minus k. Here this left side, right sides are equal, means that is exactly the points of intersections of these two graphs. Points of intersections of these two graphs. Now imagine that the second graph will be there like this. Now the equation is satisfied by maximum number of x values, means for these two graphs, its a number of points of intersections are maximum. For these two graphs, number of points of intersections are maximum, because the point of intersection is the point which will satisfy both the equations, means both equations are balanced, both sides are balanced, means that is exactly the solution of that equation. So the solutions are maximum, means their point of intersections are maximum. So the first curve is like that, and the second curve is nothing but the upward parabola. You can imagine that second curve upward parabola, you can pull it up and push it down. If the suitably it is pulled it up, there cannot be any point of intersection. But when you push it down, there will be the maximum number of points of intersections are 2. That it has the maximum number of points of intersections when the vertex of the parabola, that is 0, minus k, is below the point 0, 1. If the parabola is pulled up, then there is no point of intersection at all. Number of points of intersections is 0, means there is no solution for the first equation. Now, when the vertex is below the 0, 1, then there will be maximum number of points of intersections. Therefore, that minus k must be lesser than 1, means k must be greater than minus 1, means k must be there in the interval -1 to infinity. This is exactly the range of k, so that the above equation has maximum number of solutions. So this is the answer. So most of the times, if the problem is given like that, one complicated expressions are given in both the sides, for the number of solutions, we have to imagine both sided graphs separately, and their points of intersections are exactly the solutions of that equation. Okay, right. This is the way. If you imagine the things geometrically, things can be solved very easily. Now let us see the next problem. What is the range of this function? F of x is equal to log of 2 minus log of 16 sine square x plus 1 to the base √2 here to the base 2 for the first one. So to find out the range of a function, right, to get the range, first of all, domain of the function is required. So in the domain of that function, we have to see for the maximum and minimum values of that function. So the very first thing, I am trying for the domain of the function. So look here, fx is equal to log to the base 2 of something. Log to the base 2 of something can be defined if that something is a positive only. That something is 2 minus log to the base √2, 16 sine square x plus 1 must be positive. So from this, it happens that log of to the base √2, 16 sine square x plus 1 must be lesser than 2. So from this, 16 sine square x plus 1 is lesser than √2 whole square, which is 2. Means 16 sine square x is lesser than 1, means sine square x must be lesser than 1 by 16. So for the above function is defined for those values of x such that sine square x is lesser than 1 by 16. By keeping that sine square x is lesser than 1 by 16, let us try to find out the range of that function f of x. Now from here again we are going back. 0 less than or equal to sine square x less than 1 by 16. Sine square x is greater than or equal to 0. So therefore 16 sine square x plus 1 will be there in between 1 and 2, cross multiplied, and 1 is added in both sides. So on this one, logarithm to the base √2 is applied. Then left side becomes log 1 to the base √2 will be 0. Right side will be log 2 to the base √2 will be 2. So log of to the base √2, 16 sine square x plus 1 has both bounds, upper bound is 2 and lower bound is 0. So for that, minus is multiplied and 2 is added in both sides. Then 2 minus log of 16 sine square x plus 1 to the base root 2. That quantity will be there in between 0 to 2. On that one, logarithm to the base root to the base 2 is applied. So here left side log 0 to the base 2, right? Log 0 is not defined, but that value will go up to minus infinity. Okay, so that quantity lower limit will be minus infinity and upper limit will be log 2 to the base 2, which is 1. Therefore, the overall range of the given function is from minus infinity to 1. Okay, so this is the way we are supposed to solve it. So sometimes to get the range of the function, we need to evaluate the domain of the function. So in the process of evaluating the domain of the function, we wanted the condition on the sine square x. Sine square x maximum value will be 1, but here up to 1 it is not permitted, because that logarithm can be defined on only positive numbers. To become that quantity to be positive, sine square x must be lesser than 1 by 16. By taking that condition, we have evaluated the range of the function. Okay, so this is the way it is required. Let us see the next problem. The domain of f of x is 0 to 1 open interval. Domain of f of x is given there, 0 to 1 open interval. Then what will be the domain of the function y is equal to f of e power x and f of log mod x. F of e power x and f of log mod x. Because we know that f of x domain is 0 to 1. Means fx can be defined when x is in the interval 0 to 1. But in the y, f of e power x, x role is played by e power x. Therefore, e power x must be there in the interval 0 to 1 and log mod x also must be there in the interval 0 to 1. Right? So then only those functions can be defined. That is, e power x is playing the role of x. It should be there in the interval 0 to 1. Here in this one, log mod x is playing the role of x. That is also there in the interval 0 to 1. So satisfying these two conditions, what are the possible x's? Let us see. When x is there, e power x is there in the interval 0 to 1 means x must be there in the interval minus infinity to 0. And log mod x is there in the interval 0 to 1 means x must be there from minus e to minus 1 union 1 to e. Right? And common part of both of them will be just minus e to minus 1. That is the domain of the given function y is equal to f of e power x plus f of log mod of x. In that interval only, that y can be defined. Okay, so that is the solution. Let us see the next problem. Number of ordered pairs a comma b from the set a 1 2 3 4 5. Right, so a and b are taken from 1 2 3 4 5. A has 5 choices, b has 5 choices. Total number of choices are a comma b. Choices of a comma b are 5 into 5 up to now. But the condition, let us see. So that this function f of x is equal to x cube by 3 plus a by 2 x square plus bx plus 10 is an injective function on real numbers. Injective function means it is one-to-one function. One-to-one function means there is no turning point for the function. One-to-one means there is no turning point. If the derivative of the function is either totally positive or totally negative, then it becomes one-to-one automatically. Now you calculate the f dash of x, x square plus ax plus b. Because x square coefficient is positive there, I can make it to be totally positive for every x. So fx is x square plus ax plus b. must be greater than 0 for each and every x we are expecting now. For each x, that expression must be positive. A quadratic, which is upward parabola, which is positive for every x, means its discriminant must be less than 0. That is, the discriminant is nothing but a square minus 4b must be less than 0. That is same as a square is lesser than 4b. Now A has 5 choices, B has 5 choices. In such all 25 possibilities, in how many possibilities this a square is lesser than 4b is satisfied? Let us see now. First of all, let us take a is equal to 1. Once a is equal to 1, 1 must be lesser than 4b. Then b has the choices 1, 2, 3, 4, 5. Means b has 5 choices. That 5 choices are 1, 2, 3, 4, 5. Right? When a is equal to 1, b has 5 choices. When a is equal to 2, the equation becomes 4 is less than 4b. 4 is less than 4b. In that one only b is equal to 1 is not allowed, because 4 is less than 4 is not true. When a is equal to 2, b cannot be only 1, but 2, 3, 4, 5, 4 choices are there for b, right? That 4 choices are 2, 3, 4, 5. Similarly, when a is equal to 3, then 9 must be lesser than 4b. 9 is lesser than 4b is possible when b is equal to 1 is not fulfilled, b is equal to 2 is also not fulfilled, b is equal to 3 onwards it will be fulfilled, b is equal to 3, 4, 5, 3 choices are. When a is equal to 3, b has 3 choices. When a is equal to 4, 16 must be lesser than 4b. Then in that case, b has only 1 choice, that is 5. Right? And when a is equal to 5, b has no choices at all. So the total number of such ordered pairs are nothing but the 13. What are those 13? If you take a1, b has 5 choices. That is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, like that. 2, 2, 2, 3, 2, 4, 2, 5, like this. So the total number of choices are 13. Such a number of pairs of A and B are nothing but 13 choices. Okay. So it is like that. Now let us see the next problem. The problem is that if flower of x and step of x denote the fractional and integral parts of x. For any real number x, flower x is the fractional part, step x is the greatest integer function part. And simply ordinary bracket of x, I am defining like that, defined by 2 times step x minus flower x when x is lesser than 0. When x is greater than 0, it is defined by step x plus 3 times flower x. This is the way ordinary bracket of x I am defining. This is new bracket of x I am defining. So according to this new definition, then what is the solution of the equation ordinary bracket of x is equal to x plus flower x? What are all the solutions of x plus flower x? This is exactly the problem, right? So very naturally, ordinary bracket of x is defined in 2 pieces. One is x is less than 0, other is x is greater than or equal to 0. Therefore, let us take 2 cases separately and let us solve them. So very first thing, when x is greater than or equal to 0. When x is greater than or equal to 0, from the given definition, ordinary bracket of x is step x plus 3 flower of x. That is substituted in the given equation. Therefore, step x plus 3 flower of x is x plus flower of x. Now you can cancel one flower of x, and remaining flower of x can be replaced by x minus step x. Always flower of x, that is a fractional part of x, is always x minus step x. That you replace and work out with step x. When you replace that and simplify that, flower of x is replaced by x minus step of x, that is x plus x minus step of x. That is a step of x. It's not flower of x. Okay. So that should be step of x. So from that step of x, you cancel it. In the video, it is printed as a flower of x. Last one. This flower of x printed as a flower of x, but it is not the flower of x. It should be step of x, because above flower of x is replaced by x minus step of x. That should be step of x. When we simplify that, whatever you can cancel them, you cancel it, you will get x is equal to step of x. That is all real numbers where x is equal to step of x. X is equal to step of x is possible when x is integers. Here we are working in x is greater than or equal to 0 case. So all the integers x is greater than or equal to 0 means x is equal to 0, 1, 2, 3, and so on like that. All non-negative integers. All right. When x is greater than or equal to 0, in this case, all non-negative integers will be the solutions of our equation. Now, let us see when x is lesser than 0 case. When x is negative, then ordinary bracket of x is nothing but 2 times step x minus flower of x is nothing but x plus flower of x. When you simplify that, 2 step x minus step x, wherever the flower x is there, that is replaced by x minus step of x. Here it is correct. So when you simplify that, 3 times step x plus step x is equal to 2x plus x, which is same as the 3x. That is 4 step x is equal to 3x. You got it. That implies that step of x is equal 3 by 4 times the x. All right. Step x is equal to 3 by 4 times the x. Satisfying that condition among the negative numbers, single x is also not there. Among the negative numbers, single x is also not there. Therefore, there is no single x also in the negative side. Therefore, the overall solutions are the complete non-negative integers. That is the all non-negative integers, right? Now let us see the next problem. What are the ranges of a and b for which e power modulus of x minus b minus a modulus is equal to 2 has 4 distinct solutions are. That equation has 4 distinct solutions, right? Modulus of e power modulus of x minus b minus a must be equal to 2. So that is, if I remove the modulus in the numerator, e power x minus b modulus minus a is equal to plus minus 2 will come. So one of the part I am trying to trace its graph. So yet x is equal to b, right? So e power modulus of x minus b will become 0. So that graph will be like this. That is e power x minus b minus a. This case, you see when x is greater than b only. This graph, when x is greater than b only, you see that. Then in that case, modulus of x minus b will become x minus b. Now, when x is lesser than b, then modulus of x minus b will be, that is, e power b minus x minus a. That graph will be there like this. These two graphs, these two pieces are given like that. That above piece and here the above piece are taken there. These pieces, y is equal to e power modulus of x minus b minus a. That intersects the line x is equal to b at 0 comma 1 minus a, right? This 0 comma 1 minus a, if it is below the line y is equal to 2, then that line meets these two pieces of the graph at two distinct points. Y is equal to 2 meets these two pieces at two distinct points. Then similarly, when you take it in the down, y is equal to minus 2, there also 2 points, then totally you will get the 4 points. Now enough to calculate the condition when here you are getting the two solutions here. That is the point of intersection 0 comma 1 minus a, that is y coordinate 1 minus a must be lesser than the 2 there, lesser than the 2 and greater than the minus 2. That is for below part of the graph. For below part of the graph, I did not draw in the diagram. You can imagine that. That is 1 minus a must be lesser than 2 and greater than minus 2. Then from that, a will be greater than 3 and a will be lesser than minus 1. A will be greater than 3 and a will be lesser than minus 1. So the range of a will be minus infinity to minus 1 union 3 to infinity. And with b, what happens? Just as you keep on change the b, that vertical line will move here and there, and y is equal to 2 line infinite that side, this side. Therefore b can be there anywhere on the real line. Therefore b can be any real number. So b can be any real number, and a is in the interval minus infinity to minus 1 union 3 to infinity. So this problem can be solved like this in simple way, right? So like this, in my next videos, other problems are going to come. Please do watch, like, share, and subscribe these videos. I wish you all the best.